How did a honeybee discover nothing? What if zero isn't a human invention? And why did it take us 1,500 years to catch up? Can a creature with no language understand nothing?
For 2,000 years, humans believed the idea of nothing was their invention. In 2018, in a Melbourne lab, a honeybee disagreed. It flew, without instruction, to the empty card. She had not been taught what zero was. Nobody had explained it to her. She had simply worked it out. Her brain weighs less than a grain of rice. It holds under 1 million neurons. And in the time it takes you to finish this sentence, she had understood a concept that took human civilization 1,500 years to write down. Here is what makes this strange. The question, can bees count to zero, sounds like a children's riddle. It is not. It sits at the center of one of the longest arguments in cognitive science. The argument is about what makes human minds special, and whether the answer is as flattering as we like to believe. Zero is not just the symbol you draw on a page. It is the idea that nothing, the absence of anything, can itself be counted as a quantity. That sounds simple. It is not. The Babylonians used a placeholder for nothing around 2,000 years ago. But they did not treat it as a number. The Greeks rejected the concept outright. It took until the 7th century, when an Indian mathematician named Brahmagupta wrote it down in a single line, for zero to enter mathematics properly. From there, it traveled slowly across the Islamic world, into Europe, and eventually into every calculator in your pocket. That is a 1,500-year journey. And the bee did it without a single word of language. The team behind the Melbourne experiment, led by Scarlett Howard and Adrian Dyer, published their result in the journal Science. They had set out to test something modest. What they found is more uncomfortable than they expected. Because if a creature with under 1 million neurons can grasp zero, then the question is no longer how clever the bee is. The question becomes one about us. Here is how they tested her. The researchers placed a wall in front of the bees. On the wall they hung 2 cards. Each card had a different number of black shapes, circles, triangles, squares. Sometimes 1 shape, sometimes 2, sometimes 3, sometimes the card was blank. The bees were trained to choose the smaller number, land on the card with fewer shapes, and there was sugar water. Land on the card with more, and there was a bitter taste. Bees learn fast when food is involved. Within a few days, they were sorting the cards correctly. 2 beats 3, 1 beats 2, easy. Then came the test. The researchers showed each bee a card with 1 shape, beside a card with nothing on it at all. An empty card, no shapes, no information, nothing. The bee flew straight to the empty card. She had never seen it before. She had not been trained on it. She had only been taught a rule, choose the smaller number, and she had decided, on her own, that nothing was smaller than something. That is not pattern recognition. That is what mathematicians call ordinal numerical understanding, placing zero in its correct position on a number line. Below 1, below 2, below 3, the same cognitive operation a 5-year-old child performs when she learns to count backwards. This is honeybee numerical cognition. And until 2018, it was widely assumed to be impossible. The 2018 science paper has now been cited thousands of times. It sits inside a broader body of insect intelligence research that has been quietly rebuilding our picture of what small brains can do. Lars Chitka, in his 2022 book The Mind of a Bee, devotes an entire chapter to numerical cognition in his colonies. He calls it one of the strangest results in modern entomology. But there is one detail in the Melbourne study that the news coverage almost universally missed. And it is the detail that changes the whole story. Many people think the bee's feet is a charming party trick, a clever animal doing something cute, the way a dog learns to fetch the newspaper. The research says something more uncomfortable. The Howard and Dyer team did not just show that bees could discriminate the empty card from a card with shapes. They showed that the bees treated 0 as a number on a line. That is, the bees correctly placed 0 as smaller than 1, smaller than 2, smaller than 3, in the correct order. They could rank it, they could position it. They were not just noticing absence, they were doing arithmetic. And here is the part the news coverage almost universally missed. Honeybees and humans last shared a common ancestor around 600 million years ago. That ancestor was a small, soft, marine creature with no real brain to speak of. There has been no shared evolution of higher cognition between us and the bee. The bee's brain is not a simpler version of ours. It is a completely independent solution to the problem of understanding the world, which means that when both species can grasp 0, separated by 600 million years of independent evolution. The conclusion is not that bees are smarter than we thought. The conclusion is something else entirely. The concept of 0 may not be a triumph of human invention, it may be a property of how any neural system represents the absence of something. A feature of brains, not a feature of culture. Here is the central question, then, if a honeybee can understand 0, what does that say about what humans actually do that is unique? The answer, when you sit with the research long enough, is uncomfortable in a specific way for most of recorded history. Humans have built our self-understanding on a single assumption that the abstract concepts we use to navigate the world are inventions of human culture. We thought we invented 0. We thought we invented the idea of nothing. We thought language built the bridge that allowed us to think about absent things at all, and in 2018, a bee with 1 million neurons, no language, and no schooling, walked across that bridge as if it had always been there. The implication is not that bees are clever. The implication is that some of what we call human intelligence is not intelligence at all. It is cultural memory. It is the slow accumulation, over generations, of permission to notice things our brains were already equipped to notice. Brahmagupta did not invent 0. He gave humanity permission to write down what individual minds had been quietly capable of all along. There is something to sit with here. The bee in the Melbourne lab did not know she was making history. She did not know there was a 1,500-year argument she had just walked into. She did not know she was disturbing an entire human story about ourselves. She was looking for sugar. She used what she had: a brain the size of a grain of rice, a rule she had been taught, and an instinct to choose the smaller number. The rest, we have added. We did not invent the capacity to notice nothing. We invented the habit of writing it down. We did not invent intelligence. We inherited a piece of it. The way every creature with a nervous system inherits a piece of it, and we built libraries on top. She just did what worked. The story belongs to us. The honeybee is not the only small brain to have done something we thought was beyond her. In the same years that Scarlett Howard's bees were sorting cards in Melbourne, a different lab was watching a different creature do something even stranger with numbers. A spider, a jumping spider that does not just count. She plans, she holds a goal in her mind for minutes at a time. Even when the goal is out of sight, we will look at her neck.